All right. In this section, we're going to review a little bit about rounding and comparing decimals. These are topics that we've already talked about in the support class, but it's been a while, and we're going to start to do a lot of this, especially a lot of comparing decimal numbers in chapter 3. So I want to make sure that we are all comfortable and familiar with doing this, right? So first of all, let's review a little bit about rounding. Okay, so to round a decimal, we look at the digit that comes after the digit that we want to round to. And if the digit is 4 or less, we keep the number before it the same. If the digit is 5 or more, then we increase the number before it by 1. And then we drop all the remaining digits. So as I go through these examples, feel free to pause and make sure that you can do this on your own. So pause the video, try out the problem, and then see if you get it right. So example 1 here says that we want to round to 3 decimal places. So if we're starting with the number 3.14159, which is basically pi, right? It's the first several digits of pi. If we want to round this to 3 decimal places, we want to round to this digit here. We're going to look at the number that comes after it, which in this case is a 5. Since it's a 5 or more, that means we're going to move the third digit up 1 and drop all remaining digits. So this would be approximately 3.142, okay, if rounded to 3 decimal places. In a similar way, 2.57982, we want to round to the third decimal place, so we look at the fourth one. It's a 5 or more, so this 7 becomes an 8, and we drop all remaining digits. Okay, looking at this one, we want to round to the third decimal place, so we look at the one that comes after it. It's a 9, so we round the 6 up to a 7. Okay, but we don't always round up, of course. We'll see an example where we don't round up, where we just round off. But let's do the second set, right? It says round to 4 decimal places. Well, to 4 decimal places, this one would be 3.1416. Okay, and this one would be 0.25. Okay, so this one's kind of a tricky one because the fourth decimal place is that one, and the digit that comes after it is an 8, which means we need to round the 9 up 1, but 9 has nowhere to go. So really we can kind of think of it like we're going to take the 79 and round it up to 80. Okay, so this would be 0.2580. And then finally for part C, we have 0.0969. That's the fourth decimal place. And then the fifth decimal place is a 2, right? It's less than 5. And so we're just going to drop those digits and we're not going to change any of the numbers. This would be approximately 0.0969. Okay, so that's just a brief review of how rounding works. Now let's talk about comparing decimals. If you're comparing 2 decimal numbers and they have the same number of decimal places, then it's really easy to compare them, right? It's pretty obvious which one is bigger and which one's smaller. When they have a different number of decimal places, it can sometimes be a little bit more confusing. And so if you're not totally comfortable comparing decimal numbers, what you could do is just add zeros to the end of the decimal so that the decimals we're trying to compare have the same number of digits. Okay? So for example, if we're comparing 0.2 to 0.05, these numbers do not have the same number of digits. So what I might do is add a 0, okay, to that first number. And now they both have 2 decimal places, so they're easier to compare. And it's pretty obvious that 20 is bigger than 5, and therefore 0.2 should be bigger than 0.05. All right, so that's the inequality that should go in that blank. If I'm looking at part B, on the other hand, these decimals already have the same number of digits. They both already have 2 decimal places. And so I can compare these really easily as they are, right? Obviously 2 is less than 5, and therefore 0.02 would be less than 0.05. So go ahead and pause the video, and I'm just going to fly through and give you my solutions to each of these, but go ahead and pause the video and give them a try on your own, okay? I'm not going to show my work by writing out the extra digits, but that's something that you can do if you feel like you need to in order to get the right answer. That's totally fine. So, okay, so 0.0201 is less than 0.05. 0.201 is greater than 0.05. And 0.2001 is also greater than 0.05. Looking at part F, 0.1000 is the same thing as 0.10. 0.15 is bigger than 0.10. 0.01 is less than 0.10. And 0.0193 is also less than 0.10. Okay? 0.0087 is also less than 0.10. Okay, moving up to part K. This is greater than, still greater than, less than, equal to, and less than. Okay? So again, just a brief review. Hopefully that's helpful to some of you, and you'll have an opportunity to practice this in this assignment that corresponds to this lecture.